Tawela le kgono a re bolela ka derivatives tša n5 re tšwele pele ka one side question paper tša rena. So question paper tlo answera le kgono ke ya 29 March 2018. So ndo ka ideang go gore o pause video pele o practice di derivative tšeki, then after ge ke di dia o compare the answer tša gago le rena wa kwešiša na. So e tlo go thuša too much tabe. So a re lebele number 1 ke question tše 5 ma go derivative tša nako, so e tlo re tša nako re di fetše ka mokana ga tšona. So number 1 is determine the derivative of f of x mo e leng gore e lekana le negative 3 all over x to the power 7 from the first principle. Number 2, calculate dy over dx of the following by making use of derivative of sin x and cos x, as well as the roots of differentiations. Y equals to log to exponent log of cot x. Ba hint bar a to exponent log of base a of x equals to x. Number 3, determine dy over dx in each of the following cases. Case number 1, bar y equals to sine angular ba arc sin x r minus pi to exponent t. Number b, y equals to the ln of power 3 to the power 3 angular ln yaba x yaba cos yaba inverse of cos x to the exponent cos x, and cos x yaba exponent yaba raised to exponent 0. O dira ka exponent di dintši mo gore sontse bona go ira mara a tla bereka ka yona re ntse re solve. Number 4, calculate dy over dx with the aid of logarithmic differentiation if y equals to x to the power ln x. Number 5, determine dy over dx of implicit function y sine times sine of angular yaba x squared equals to x sine angular yaba y squared. So kantle go senya nako a re lebele number 1. So number 1 is determine the derivative of negative 3 all over x to the power negative 7. So o ka write the equation e ga botse wa re f of x a gago o tloša fraction go bereka ka fraction ga ntšintši go hlakantša o thoma go kane gore no bereka kang gore 3 because ke negative if nearly 3 to exponent x 7 e be tlo ba 3 multiplied by 1 over x to the power 7 mara gore ke negative e ba positive even ba mara gore ke negative e ba 3 to exponent 7 ska hlakantša ka gore gantši ba rata go idea positive, ba rata go idea negative, ba rata gore e be ntolane man, I mean ba rata gore e be positive ka fast then go ya go ntše e be negative mara ge e so ke positive. So from first principle ra tseba gore f primary no e lekana le the limit ge h approacha 0 wana mo bona f of x mo bona x fakala x plus h minus f of x ka mokgweleng ka wana all divided by h wa itswara. So f of x are nashi are substituted in the one fang f prime ele kana le the limit ge h approacha 0 o ngala the limit fitla mafelelo gore ke tlo gatella tayo ngala limit fitla mafelelo gore ska tla ka ra lo witwe juma ga rona tsa mongala f of x ka mokgweleng ka wana then or minus 3 into mo bona x ba fakala x plus h but x arna is raised to the exponent 7 we level the tabe exponent 7 minus f of x arna le gone ke minus then we ka ra brackets or minus 3 into x to the power 7 in wana ka mkho tabe nya ke rule then all divided by h go substituting gore ka metse o ngwala formula after ngwala formula wa substitution so lo tsa lo substitution di ba di formula go lebela ga change as kana wa answer straight substitute re bona o dia so maro ka lebelela go tha ga yona re simplify ya ba the limit f prime equals to the limit re h approach as 0 while minus 3 into x plus h to the power 7 minus times minus ke positive 3x to the power 7 why bona ke retabe then all divide by h so mara before tswela pele re na le x plus h to the power 7 edo sonjere so re simplify then go simplify e nyaka binomial theorem binomial theorem ere sonjetse binomial theorem from n4 or binomial theorem idea from n4 logo high school binomial theorem got idea binomial theorem er x plus h to exponent n equals to first of all raise x to exponent n ka mogwele nga ona or plus the derivative of this one eba ja derivative of this one ja n y multiplier yaba n or minus 1 and yaba n multiplied by x to exponent n minus 1 then h mobile to the power 0 l1 then so on then more introduce h to the exponent 1 multiplied by h plus n into n minus 1 all divided by 2 factorial 2 factorial like 2 times 1 so no so really 2 and I bet that much into x into n minus 2 multiplied by h squared oga lebelela x to my the power of x to my le whole ya decrease ganyana go gola exponent ya h so from more to tlogela to 3 terms ka sengwa lo fitla mafelelo then from one substitute ka mo ka problem e ke fere feeling yon then ara ya ba x to the exponent n plus exponent there again ke 7 rx 7 minus 1 to exponent 6 multiplied by h plus 7 into 7 minus 1 all over 2 factorial which is 2 times 1 multiplied by x into n minus 2 multiplied by h squared then all our x plus h out to the exponent 7 elegantly this one to 3 terms and have it to 3 terms then I'll substitute most of the on post video I level or night la juang then I'll continue ka yona fitlela ukwishisha the limit re h approach 0 more one o kernel minus 3 p fakela minus 3 into x plus h to exponent over x to the power n plus 7x to exponent 6 multiplied by h plus 7 minus 1 is 6 by 7 by 3 is 21 by 3 gape ke 21 e ba 42 42 by 2 42 by 2 e ba ngone 42 by 2 42 by 2 e ba 21 then or plus 21 x to exponent n minus 2 multiplied by h squared. So fela o try o solve logic ka hlogo wa thusha means ka go save la na ka ra test busy personal calculator the whole day and calculator lo no gra ile go function e wrong go di shed posh so today no calculate the basic things with plus the minus it's easy man. Try ka hlogo then equals to the limit sh approach 0 then we multiply by 3 multiplied by x to exponent n ba minus 3x to exponent n 3 multiplied by negative 3 multiplied by positive 7 ba minus 21 x to exponent 6 multiplied by h 3 multiplied by negative 3 multiplied by 21 is 63 and obvious minus 63 x to exponent n minus 2 multiplied by h then 1 plus 3x to exponent 7 all divided by h. Then one thing or f of x are sonje cancel. If I cancel it's only mistake as a 7 as a n is 7 as a n 7 then they are canceling f of x if I cancel it's only more mistake or level up so tell ka yona the limit h approach 0 and then we should get minus 21 x to exponent 6 multiplied by h minus 63 x to exponent n minus 2 multiplied by h squared squared. I'm going to an example of 1 squared or fana example of 1 squared in then all divided by h. Then go tla le ba the limit h approach 0 and h is a common factor or h shall minus 21x to exponent 6 minus 63x to exponent n minus 2 multiplied by h according to a common factor all divided by h again. Then h are cancel division h divided by h is 1 while the limit h approach 0 or minus 21 x to exponent 6 minus 63 x to exponent n minus 2 multiplied by h. Then after mo ke go mo substitute h I want to substitute from osalo whole then subtract h also ngala the limit or substitute or minus 21 x to exponent 6 minus 63 x to exponent n minus 2 hijarna yaba 0 yagi 0 shichika minus 21 x to exponent 6 then the final answer mara wena le nako o file so we prove lo wena o ba we lebeletse ka masaiteng f of x are le rapa kung we prove f of x are by the king minus 3 over x to exponent 7 so on in nako during exam when you prove fast or na ya lekana na so the mistake anyway we want to shumisha power rule or any rule you want to apply o shumisha quotient or na le final na le fraction or o shumisha power rule or simplify over minus 3 2 exponent 7 again. 2 exponent 7. So go shumisha power rule multiply ka 7 over minus 21 more minus 1 over x to the exponent 6. Ya ra gore final answer wa dia swana ka maside go ne nako. Then our level number 2. So number 2 here, y equals to 10 all raised to log of cot x, and ba hint bare if a is raised, if a to the power log of base a of x equals to x. So we have base of 10. Y are nadia, y are nadia cot x. And about shumisha sine and cosine to find the derivatives. So razor cot x again. Razor y are nadia cot x again cos x over sin x. So what na the fraction that rekashumsha quotient rule. Quotient rule is if f of x, f that a capital letter, equals to g of x and small letter f of x. Therefore f prime f prime ngala f of x ka mogweleng ka bona ka godimo, ngala f of x ka mogweleng ka bona ka godimo, o multiply ka derivative ya g prime o minus ngala g of x ka mogweleng ka bona o multiply ka f prime all divided by f of x ya ka fase e be squared. Then mortary here na go limit ki g of x, then there are ki f of x. Then we substitute as straight y prime le kanale f of x, which is ki ka fase ngwana sin x ka mogweleng ka ona, multiply the derivative of g of x. Derivative of g of x king ya cos king minus sin x minus g of x again cos x ngala cos x multiply by f prime or f prime ke ga side derivative of sin rather again ke cos while cos x all divided by f of x again sine, which is sin x all squared. Then I to alone sine multiply by sine ki negative sin squared x minus cos multiply by cos ki cos squared x all divided by sin squared x. So we can change negative as a common factor because according to our identity, r sin squared plus sin squared x plus cos squared x ile kana lo 1. Then re go shumisha identity ra so nje negative as a common factor, negative 1 as a common factor, the remove by positive. Then roll negative into sin squared x plus cos squared x all over sin squared x. So that's all sin squared x plus cos squared x go 1 or negative 1 all over sin squared x, and that's all sin squared x again ki cosec squared, then our negative cosec squared x or ngere a tseba gore metse re ka solve in many different ways. So arere o wetla mo wile ga wetla mo over wa nyaka go shumisha a different method, a different identity mhlomo. So wile go wetla mo are minus sin squared x all over sin squared x minus cos squared x all over sin squared x. So sin squared x over sin squared x king ke minus 1 minus cos squared x over sin squared x king ke cot squared x. And there are zero from identity and 1 plus cot squared x equals to cos x squared x. So come go positive mara ka marna lead negative ragel negative ya equals to minus cos x squared x ka go divide ka negative yo weja moto ya positive. So final answer one is still cos x squared x, and you are right Lwena. So actually mpida rebelle number 3. So number 3 ere number 3a equal to number 3a and b. Number 3a ere y equals to sine of angle ya x and x minus pi to exponent t varanda banyaga dy over dx. So on null function j null function number term and null function wegar and on null constant. Then y prime yaba derivative ya sine king ke positive cos wal cos ushumisha chain rule. So derivative ka ntle ya ka cos of ungwala ka ka mkhwele ka ona yaba arc sin x wa multiply ka the derivative ya ka, and there are zero the derivative of arc sin x dx of sin arc sin x elegana 1 over the square root of 1 plus x squared. Ba fa yone in most cases mara go nyaka go improve one question di rata go di prove or na prove or ntwe elegana le prove ka ra a different video ya mkhuto. So arjele bere multiply ka derivative ya ka gare e leng gore ke 1 over the square root of 1 plus x around over x then over x squared, and the derivative ya constant king ke 0 or gana mo village. Then again number b ile y equals to the ln of 3 into cos inverse of exponent ababa cos x yaba exponent cos x yaba exponent 0. So in there or anything raised to exponent 0 ko 1 then or y arna ke the ln of 3 ge le mo din ra re ya ka re ln as a whole ere ke ngwana go tsore go jana o ntshana era gore 3 ge le gore batho ge le 3 na ne ke 3 mo exponent 3 ba the ln of cos inverse x second function of cos of exponent 3 wana 3 ka ra ya ka re jante ka mokana ga yona, then cos in number to the power 0 1 the number to the exponent 1, then banyaka dy over dx over dx. Then according to chain rule we just 3 multiply ka yona minus 1 ngwala nteng ngolonga magare ka mkhweleng ka ona ngwala 3 ngwala ka gare ka mkhweleng ka ona ya ba the ln of second function of cos x all to exponent 3 minus 1 ke 2 multiply by derivative ya function a ka gare la ka gare o na le function ke chain rule di re šomišitšeng ona o duile re bereka ka ntle re ka gare o na le ln o na le cos le gona is an angle then derivative ya ln ke multiply by 1 all over se se leng ka gare ga ln angle ya ln which is 1 cos inverse of x then multiply derivative ya cos and ratse whatever multiply by cos inverse is on the real arc sine or arc cos cos inverse equal to 1 second function of cos equal negative 1 over the square root of 1 minus x squared lona ba rata gore e prove gore le kana le equal 1 over the square root of 1 minus x squared equal minus then ke final answer o feditše gona seno mo sa kwešišeng pause o lebelela gabotse before tšwela pele any problem you read and we pause it before then we understand it before tšwela pele a tšwela pele ka number 4 ere calculate dy over dx of y equals to x to exponent in of x with the aid of logarithmic function with the aid of logarithms. So we introduce a log both sides or ln y equals to ln of x to exponent ln x. So tawagana wa ln y equals to that's our original exponent go log re khona go sha exponent mo fase e ba ln x multiply by ln x then re get derivative when ka mo na le product rule na le function je pele di multiplier na derivative ya ln ra tseba ke 1 over y because I differentiate with respect to y re ngwala dy over dx multiply by derivative ya ln x again go 1 over x multiply by ln x plus derivative ya ln ya bobedi go 1 over x if 1 over x multiply by function but function equal 1 that's when we ln x multiply by function la bobedi which is ln x product rule if g of x multiply by f of x f prime ya gago e legana le f e kgolo re tla shumisha f pele f ke e kgolo ke incane e legana le under g prime multiply by f of x plus f prime multiply by g of x then o ja wena rena g of x e bile if mo under g of x ke and f of x okay then wa substitute mo formulaing ya 5 then go rena ka dy over dx or dy over dx ra multiply ka 1 both side ka y both side ya ba y into e multiply by less than ln x over x plus e multiply by ba ln x all over x then ln x plus ln x is going to 1 dia swana wa ya go njebeleng tloa mathomo ngwala wa ya ka mkhweleng ka wana wa ya go bele x to exponent ln x multiply by 2 ln x over x then differentiate them. So all of them could just the differentiation rules very important what it's about. So our level question number felelo number 5 or 9 or 5 area the number felelo area y equals to or determine dy over dx of implicit function. Implicit function da gore o differentiate both sides, both x and y. So and o ga lebella o sentse tsona one function tše kae o kgona go differentiate, or o ga tsone function tše kae o end up ba confused. Function ya mathomo ke y and ya bedi ya ba sine angle, and ya boraro ya ba x squared equals to L4 ke x, L5 sine lona sine mfl ya ba y squared. Now function j 1 2 3 4 5 6 6 and je lo sentse di differentiate ka mokana ga jona with respect to y and with respect to x. Here we differentiate with respect to y on ngwana dy over dx o fetsa we differentiate mara ya x when you differentiate ka mohweleng ka ona. So and which rules do we have mo gape? Rules tše re nang le tšona, re na le product, two function they are multiplying, and the two function they are multiplying, re na le product. So a differentiate da mathomo leg function ka gara function, leg function ka gara function, quotient rule. Then according to product rule, if on a g of x, if f of x are y whole, ndo ya senya ka rapa ke tse y sarap ara tšwele pele. If f of x ele kana le g of x and f of x incane, then f prime ya gago ele kana le o ka kgetha no nya go differentiate efe pedi between the two, because there is g of g prime multiplied by f prime, or o ka re f prime multiplied by g, ka gore mo re na le positive mara ge be negative maybe tla ba different story, like also na le quotient rule, then or f prime multiplied by g of x ka mohweleng ka ona, ga gone division mo ke product rule. Then ge re lebele tša mathomo ka mogodimo re ka differentiate y, re differentiate with respect to y re ngwala dy over dx ka gore ke y fela, derivative of y ke 1 multiply by the sine of x squared we ngwala ka mohweleng ka ona plus ngwala y ka mohweleng ka ona, derivative of sine ke cos, then o multiply ka cos of ngwala x squared ka mohweleng ka ona multiply by function ya ka gare ya ba 2x ya ba equals to o tla go ya bobedi, derivative of x e ba 1 man, derivative lo gona o šomiša product, derivative of x e ba 1 multiply by o ngwala sine ka mohweleng ka ona le y squared ka mohweleng ka ona plus o ngwala x ka mohweleng ka ona function ya bobedi, derivative of sine ya ba cos of y squared multiplied by the derivative of y function ka ra function while 2y but with respect to y o ngwala dy over dx, then go di le so o be dx ka felo go te le di dy ka felo ka le di other function ka settle take ro nya ka dy over dx ka mo rena le dy over dx e 1 o ne rena le dy over dx e 1, then or ro tšea ka go that side ro ba le dy over dx multiplied by the sine of x squared e la ya change minus x cos of y squared multiplied by 2y dy over dx, then yaba equals to 1 multiplied by sine yaba sine of y squared, so I g on the right hand side yaba minus 2xy cos of x squared. So one dy over dx is a common factor this side. Dy over dx into brackets on sine of x squared minus 2xy cos of y squared. That's all brackets are. Then come right down, welcome coiling down. Come right over sine of y squared minus 2xy cos of x squared. Now no divide both sides. I divide both sides. Got the sine of x squared minus 2xy, the cos of y squared. Say megam sine of x squared minus 2xy, the cos of y squared. G divide the number 1, then dy over over dx like another function. Then come coiling kaona arlo garona yengwe solve problem g which derivative dorfa. Then you final answer na show ralo ga tawana ga tla na video mo re. Thank you.